Hello folks, welcome back to the HS Tech Channel. In this video we're going to keep looking at VMIS, and we're going to look at some of the other stuff that's installed on here. Now, I am already assuming that you know the gist of VMCMS networking. You know about RSCS, and you know what SNA is, and you may or may not know what PVM is. PVM is, well, consider it like poor man's VTAM. I guess it's actually a VM pass-through facility, but you can rearrange the letters and get that. So I'm going to start with VTAM, and I'm going to demonstrate these in operation. Now, this is like the most basic possible VTAM login screen. It's basically the VMESA 2.4 default that I just copied out and modified a little bit. And we have two hosts defined that we can connect to. We can use this local machine here, and we can also use our VMESA 2.4 system. However, this machine is like an isolated island. It does not actually have any other network links, so we're basically on our own. But from here, I can actually just log in as normal. And then if I note that there's a bit of a difference in color here, if I do a query names, you'll see I'm actually logged in through. Let me do that again so you don't have to scroll. You can see I'm logged in on a different terminal address rather than being up here in the, like right there, there's the operator on the operator console. You can see I'm logged in here under this VTAM service machine. But we're not here to look at this forever. I do actually have to disconnect and reconnect in order for this to work properly. And then we can also look at PVM. And this is more of the same thing, except rather than using the special VTAM service machine hook, it uses a logical device. Same way that like the Telnet 3270 works, if you know how that works, or I guess int client as it calls itself, and we'll see what that means in a second. Unfortunately, I can't talk to this remote node, but I can talk to myself. If I can spell. And you can see we're logged in on logical device 0. I'll log off of this. There we go. And then I can push, well actually I can also push PF1 to drop straight into this, but just for fun we'll actually work through PVM, and let's consider TCP/IP. So we'll log in as CMS user just for fun, and we need to do some modifications. Oop. Unfortunately, we don't actually have enough storage, or I guess RAM, to run the TCP/IP program, so we're going to load that up a little bit. Yeah, we'll just do 8 megs. We need to increase our loader table size, and then we can do netstat. And you can see everything that is currently working. Okay, apparently the FTP service has stopped, so we're going to look at that. But we got two things listening here. We got int client, which is actually supposed to be internet clients, which is the Telnet 3270 server, as you can imagine. It also does normal Telnet. However, for some unknown reason, that crashes TCP/IP. I don't know what's going on there. Of course, we got PVM too. Alright, so we can also do netstat home. And there's actually a lot you can do. Let's see if I have the help files installed. Oh, look at that. Clients, gate, and actually we'll just try it all. This is everyone that wants TCP/IP potentially. Oop. So if we telnet, we got our login screen here. And you'll see that I'm also logged in on a logical device. CMS user is also logged in on a logical device, and that's going through PVM. So we are really putting PVM and also TCP/IP to work. But I'm logged into the machine through Telnet, as you just saw there. So I can link TCP mate 592. Oop. There we go, and you can see that I'm logged on as mate. So we'll drop out of that. press enter to get back into CMS. And we can pretty much do everything else you'd expect with TCP/IP, including actually email ourselves. So we can do note CMS user at 192.168.1.62, and assuming, oh, sorry, I'm thinking with the MVS SDSF console, we're gonna actually probably need to cycle the SMTP daemon, so let's actually do that. So we get tons of junk, and at this point it's running. We'll also do FTP daemon. There we go. Now we can actually do stuff. We'll see if we can. No, actually, yeah, 1 mega storage should be enough to do this. So we're gonna do note CMS user at vmis.localdomain.net just for fun. Oh. And then, if all is good... Oh, no, okay. Yeah, this... Okay. So you can receive an email, but you can't necessarily send one. But we can definitely try. And actually... okay. Normally there's a special note exec on the TCP/IP disk, and this one is special because it supports TCP/IP. Yeah, the whole thing's written in Rex, by the way. It's just a really clever Xedit profile. Okay, but there you go. Anyway, we can sit and read this for days, but there's no real point in doing that. Let me try it again. No, it's not liking it. There's a special procedure you can do. You can do, I think, SMTP%. We'll try that too. Okay, well, RSCS is getting in the way, and it's not smart enough to defer it to SMTP. That's what actually works on newer VM versions, is it will be smart enough to defer it to SMTP, and there's an option you can override that, but in this case, we're not doing that at all. Okay, but we can also just telnet into the SMTP server. Oh. Wouldn't be complete without that. In case you don't know how to do this, it's actually really simple to talk to an SMTP server. This is literally it. And look at that, we got a punch file from SMTP. If we do a reader list, junk, of course this is one we want, we can peek it, boom, if we do receive, it gets thrown into all notebook. And of course you can pull out all your NJE messages from the all notebook file, but that's like a billion lines long, so we won't sit and read that. So there we go, we have working TCP/IP on here, and we do have working RSCS. Now, of course, that you're probably wondering, what in the world is this command? So we have to send a special message, which is kind of like a command, to the RSCS virtual machine. We want to message this machine with this user with this text. It's not so bad. We can also tell CMS user at VMIS. Hello. Now this is just going to loop. This is looping locally because it's smart enough to say, oh wait, hang on, this is the same machine name. But if you do this over a network, it's smart enough. And the way that it knows this is if we look at a file called systemnet_id. This is really, really important if you're configuring a VM system. This right here is your local node ID, and this is your virtual machine name that's running RSCS. This is nonsense. Okay, you do need to set the CPU ID, and if you're like super lazy or something, you can actually just plug in all of your hosts into here, and you can just distribute the same systemnet ID file. If you're on ZVM and you're doing a single system image cluster, you need to do that, by the way, or you'll have serious problems. But this makes the tell and note commands work over NJE. So if I do note CMS user at VMIS and then send this, it's just going to end up receiving it directly. And there you go. But if we also sent that over the network, it would also work. And likewise, RSCS would be smart enough to route it for you, assuming you told it how to route it. Okay, let's look at some configuration files just for fun, because we've looked at all this stuff, but we haven't actually looked at what it looks like to configure. And again, I'm assuming you've probably already worked with ZVM, or if you haven't worked with ZVM, here you go. This right here, this is virtualization in the 80s. This is a real thing. We'll push PA1 to drop from that. We're going to log in as PVM. There you go. This is a super new version of PVM. I have version 1 release 3, version 1 release 1, and then I have this one. And the newest one is actually from 1998, and IBM just quit updating it. I don't know why. But on modern ZVM, you can run PVM over TCP/IP over SSL. So it's literally like SSH for VM. It's really cool. So in case you're wondering how you configure this thing, make sure you set your local node ID correctly, or your language. If you want to do UCENG, you get all uppercase messages. This right here is how you define a remote TCP/IP link. Okay, note very, very importantly, there's no dot here. I don't know why. I don't know why it was too difficult for them, so they just didn't. Who knows? Link star means link to yourself, or like link with no node number, and then we're going over TCP/IP. Here's the IP, and then here's the port. 999 is the port. That's like the official PVM port. Route default to this node. Select means you can push PF1 and get like a boom, just hotkey to get into it. And then down here, if you want to do VM dumps, there you go. I have no idea. It's different message options to control what the user sees. You can look in the manual if you want to figure out what these are. I have no clue. This is just the default. And then here you go. So TCP/IP configuration. Just here you go. TCP 999 TCP/IP. This is the service machine name, and then start. Then there's also profile PVM. So this right here is going to attach our channel-to-channel adapters. We're using channel-to-channel, not BiSync, because who knows, BiSync sucks. So we're using CTC. I mean, this is not a real machine anyway, so we can do whatever we want. And then start up your links. And if you don't have your terminals plugged into your directory, you need to define them and then you need to start them. But be careful, there's a known problem on VMSP. If you define special 3270 devices, and yeah, it's like special, in this case it would be 020 3270 or graph, for whatever reason it won't work, so you do actually have to define them. And then all the stuff that's in here is just this stuff. I am actually not sure what EFG view is, but I don't think it actually does anything. I also have MPVM on here, but it's not really useful, and that's on disk D, although I probably removed it because it bugged. MPVM, and I probably need to make a full video on PVM someday, but MPVM, if you're from the Unix world, you know what tmux and screen is. Well, guess what? We have that in the VM world too. We just call it MPVM, and it works the exact same way. We'll go ahead and restart PVM. There we go. Yeah, I know, 302 doesn't actually exist. It's a shame. And we'll look at RSCS too. Now, RSCS, unlike PVM, runs under the group control system, or GCS, which is kind of like a, well, it's called OS simulation. By OS, I mean like OSVS, you know, MVS. That's what it is. So this is actually super easy to config. There's like a billion lines that we don't need to look at. Yeah. This is actually copy and pasted verbatim from a manual. So here's your local node, and please use this. This is actually really useful if you have a distributed system, because the times will automatically adjust when you get notes, or emails if you want to call them. Operator form name, no one cares about that. Reserve these channels, it's not what you think it is. Here is a link for a standard NJE line. There you go, DMT NJI. This is like the old form. Don't actually use that unless you're using the really old RSCS. This is RSCS version 2. RSCS version 1 is a nightmare. You actually generate it, and it loads not under GCS, it loads under its own system. And yeah, this is how you do SNA NJE, and you just say remote node, SNA NJE. These are all time zone offsets. Star means doesn't matter, and then RSCS NJE 0 is the remote LU name log mode. You're probably wondering what is the associated LU name. In this case, there isn't one defined, but if you're doing SNA NJE, plug it in right there, or nothing will work. Okay, this is for dialing out on bisync lines. I don't have that configured, so who cares? And then here's who's authorized to do stuff. You can also authorize remote nodes. Now, if you want an even better video on just like exposing NJE, go watch the Moshix mainframe channel video on it. It's so much better than mine, and it's pretty long, so I think it's pretty good. And there's also RSCS net VTAM list. This is just something that you would copy and paste into your VTAM configuration library, and we're going to look at that in a second, don't worry. I hope you know SNA. If you don't know SNA, this is like completely foreign to you, but it's like this horrible network protocol they had in the 80s, where you have to define everything using these awful macros. And yeah, I know, it's copied from a VMSP system. Oh well. When we start it up, there we go, RSCS networking loaded, version 2.04. Yeah, the line's not operational. It's because, guess what? Device does not exist, so we can't attach it to ourselves, and it gets attached as 400. I don't know why I haven't updated that. And then we define a bunch of other routes. And from here we can set run on and disconnect. We'll go look at VTAM. Yeah, I know everyone hates VTAM. You'll do fine. It also runs under GCS. Now this is not a full VTAM tutorial, but this is just a configuration for like an average machine that probably would have ran this. And this is what really matters. Of course, we always start with CDR, the CDRM, the Cross Domain Resource Manager. So there we go. We're on sub area number 12. That's like the, I guess you could kind of call it like the network node number, because everything's done through sub area numbers on here. Because this is old VTAM. We don't have like the fancy new routing. Nah, that doesn't exist. VMESA. Here's our remote node. Of course, sub area 1, because it's like the catch-all for all the possible nodes. Cross domain resources. This is not like RSCS like the networking. This is RSCS like resources. And so we have defined here a remote VSCS, VTAM SNA console services, and then an RSCS, remote spooling and communication services. I hate how they're so similar. And then they're both on this remote host. And you thought TCP/IP routing was bad? Boy, you haven't seen nothing. This is awful. I mean, I can't lie. This is like nonsense. This is not an SNA tutorial, but this is how you define a remote route to a remote sub area. So if we're going to sub area 1, we need to go through transmission group number 5. And of course, transmission group number 5, here it is. Here's our physical unit on our line, and then our line is address 303. This right here is just like anything that's over a certain distance away is treated as a comment. So like, you can type comments in here if you want. Oh wait, I forgot I had this defined. There we go. And that's pretty much it. this right here, here's the VSCS application ID. So in other words, this right here is like the actual hook for the equivalent to like Telnet 3270 over SNA. This is it, is VSCS, and you just log on to that application. Likewise, if you're talking to an MVS or a VSE system, you can talk to a remote TSO or KIX or NetView or whatever crazy application IDs you have defined, or IMS or anything. And likewise, if you're doing SNA, those are just not terminal applications. They're like some other special logon mode. So that's what you saw back there with RSCS NJ0. And that's pretty much it. Here's our sign-on screen. Yes, really, it's an assembly program. It's beautiful, I know. Couldn't have done a worse job myself. Okay, DTI user 0. This right here generates the, I guess you could say, sort of the miniature program that serves out VTAM SNA console services. And we do IPL GCS, and I strike return again. Okay, why in the world did my terminal freeze? Machine wait state? No, who knows? Alright, hang on, we gotta disconnect and reconnect. Oh boy. Force VTAM. Oh, we got the dreaded log off force pending for user ID VTAM. Okay, we're just gonna reboot. Oh boy. You can't see what I'm doing, but I'm over here rebooting. And just waiting on that to come up, and we should be good. There we go. Now, let's talk about writing programs. Actually, why did I log in as main? Let's log in as CMS user. Let's write some programs on glorious VMIS. Now, I know I don't have GDDM installed. That's next. We're going to do a whole expose on GDDM, which is basically incurses for the mainframe. If you from the Unix world, you know incurses is for like terminal graphics and such. But we have full bitmapped, and we also have vector graphics. I know mainframes are actually really cool, but no one thinks that's the case. Alright, so let's see what we have on here. Well, we don't have any COBOL programs. I guess I gotta write one. So let's quickly key this in. I'm not gonna make you sit and watch me type, so let me do this real fast. Boom, there we go, lightning fast. Actually, there you go. Oh yeah, we got our line numbers plugged in by Xedit. Now from here, we need to run a exec file that I hopefully have. And what this does, it defines a bunch of temporary files, because these old compilers, they were meant to be very light on the memory that they needed, so you do use a bunch of temporary files on the disk. Now we can do COBOL VS hello, and we should have a listing file, and there we go. Now I only have 2.3 for VM. The last version of OSVS COBOL was 2.4, but I only have that for MVS. Either way, look at that date, 1978. If it ain't broke, don't fix it. Also, it's not Y2K compliant, as it never would be. And then we just get a bunch of useless output. And you can print this if you want. This column over here is, of course, for carriage control on the printer. So there's special symbols for special meaning in there to control the printer's output. Like this is where you have a form feed and all that stuff. And this right here is a special carriage control line. Alright, but now we can do global, textlib, coblib vs, load hello, if I can spell that right, genmod hello, and this will of course produce a module, which is a lot longer than you think it is. It's actually decently large. This is the thing, is you wouldn't necessarily want to make the stunning realization that static linking doesn't exist. Even though this compiler is from 1978, you would actually use VS COBOL 2, which I don't think I have. I don't have. Okay, well I can install that later. But VS COBOL 2 is special because it actually supports dynamic linking. This version doesn't. So if we look at our hello module, that's massive. Yeah, and of course you want to do 3 times 7848. That's got basically the whole TextLib, aka the COBOL runtime library in it. Nonetheless, it does work. So there we go. We also have a PL1 compiler, so we can do a PL1 program here. So let me type that in. Alright, so let's compile that. My goodness, you can't use double quotes. You have to use single quotes like it's a really old compiler. That's because it is. There we go. So this right here is a slightly newer version of the compiler. This is actually the newest one you've got that runs on VMSP and just VM370 systems in general. Consider this one from about, I think it's 1986 or so. You can see this is even bigger. Yeah, it's pretty massive, but it works. But you know what we really want to do? We want to program in that filthy Unix language. We want to program in C. Let's program in C. Let's type that in. Alright, there we go. Oh. Oh, look at that. I somehow messed up in the editor. There's actually a mess up for a variety of reasons. There we go. Now this won't actually produce a listing, because what this really does is the actual compiler itself is called ccmod. Wait, no it isn't. Here, we can actually just look at the compile source code, or the compiler exec. There, sorry, it's ccprog. ccprog hello 3. And if we look at this, here's our assembly output. Really what this is a 1987 compiler that actually supports C89. How's that possible? C89 didn't exist yet. Oh, but it did. And the Whitesmiths guys who actually wrote this were the ones that figured it out. Hey, we can use the draft for the C89 standard, and that's what we'll use our compiler for. Or that's what we'll base our compiler on. And so that's the story of that. There we go. So that's basically it. That's all the compilers I have on here. I have a VS Fortran compiler. Or no, I don't. Oh well, I thought I had a Fortran compiler. I guess I need to install that from the tapes. No, there's nothing wrong with the Fortran compiler. It's just I need to install it apparently. But anyway, I think that's going to wrap it up for this one. So we looked at all the networking options, what it looks like to configure them, and all the compilers you can reasonably get on here. I don't think I have the Rex compiler. No, I don't. So that's basically it. So coming soon, we're going to look at GDDM. The amazing incurses for the mainframe. That is like 1,000 times better than actual incurses. And I will see y'all in that one. Have fun.